Hey folks, in this episode what we're going to do is going to build out a portfolio project using PostgreSQL. So at the moment I have PostgreSQL set up locally on my own machine. I have pgadmin4 set up, ready to go, and I have some data installed. If you missed it, there was a setup video I produced where we went and set up PostgreSQL. We then imported the data and then we connected different services to our database so we could feed the data in, things like Tableau, to go and see them there. If you haven't seen that video, do check the description. So for this challenge, we start here with our data for our Lego project loaded into Postgres, just in a staging folder. What we're going to do here is build out a more performance schema and build out a schema diagram. We're then going to perform some analysis on our Lego sets, and then we're going to visualize them in a tool like Tableau. And then part of this is showing our work, so we're going to then go and record the project on GitHub. I feel these are really good principles to have for any portfolio project, so don't feel limited that you have to do something on Lego here. You can pick any data set, just follow the same principles. You can do any type of analysis. You can use any visualization tool you'd like. But I feel this covers a good basis for you to go and have a decent portfolio project that you could then go and take to any employer out there and show the skills you've got. So in the setup phase, we brought these CSV files in to Postgres. We did the classic lift and shift. We didn't really care about the data types or any relationships between the tables or any constraints, but these are really good things to show that you know. So the way I want to start is by looking at the staging schema. If you right click, there will be an option for an ERD. This is an entity relationship diagram for the schema. What it will show you is this kind of map of the schema itself, and it's not very helpful. I always say there's just a collection of tables, what the field names are. There's nothing here. I can actually show you what the diagram is supposed to look like. Here's my actual entity relationship diagram. You can see that yes, it has these relationships here. You can see how you go from joining one table to another, which fields you're going to need. So ID here matches the theme ID over here. This is very helpful for navigating around the schema, for one thing, but also joining on these columns is going to be much more efficient because they've been classified as either a primary key or a foreign key. Doing this adds an index, which is SQL's way of optimizing how you would join things together. So you would find that queries run in this kind of setup will be much more performant. So we're going to build up this schema diagram. We're also going to have a look at some of these data fields. So fields like text are incredibly large storage of data. We could be a lot more performant if we actually had a specific number range of how many characters we're going to have in that string. For example, a set number, I can't imagine it being over 200 characters. We can take a look at the data and just sort of check how big these fields typically are and then set a data type for that actual range. Okay, so I'm going to go and create a new schema to go and transform this data. I'm doing that so I can keep the existing data just in case anything goes wrong. That prevents me from having to re-import the data again. Let's go hit up here, new query tool. So I'm just going to execute analysis, F5, that's done. Again, I need to go and refresh this and I can see analysis come up here. Okay, so I'm having a look at my colors table here. So I've done the schema name staging.colors. Remember in the setup we can set the path for our schema to go and just call the table names itself. But in this case, because I know I'm going to be writing to the analysis schema, I'm going to keep it like this. It's just to make my life a bit easier to know that I'm going from staging to analysis. If I was just to say select star from colors, I might get confused of which schema I'm pulling it from. Okay, so for colors we have 4 columns here: ID, name, RGB, and is trans. What we can do is work out the lengths or the maximum number of these columns to go and understand how big these data types actually are. Okay, so the query I've run here is finding the min and max of the ID fields and then the maximum length of some of the text fields. So I can see here the ID ranges from -1 to just under 10,000. Some of these lengths are very short consistently, so I don't need to allocate a full space of text to some of these. Some of these could be 1 character long, some could be 6. You may want to give that a bit more range than 28. You might want to give it, say, 50 or so. But what you'll be doing here is allocating less storage space than the full text string. So what I recommend here is looking at some of the documentation for different data types. So I've pulled up Postgres' data documentation for numerical types. So here I can actually see the range. So that ID field we had specified as a big int. So that would take up 8 bytes, but you can see the range here is massive for a number. We're nowhere near this kind of big number. In fact, we're actually a lot closer to small int, so we'll have a negative number, but also a positive number as well. You can see actually some of these wouldn't be appropriate, so small serial auto incrementing doesn't go negative, so we want to avoid these. Small integer here gives us enough flexibility for a small byte range. This is based on me knowing this data and knowing this data isn't going to change. If you were dealing with a scenario where you have a large amount of data being imported, say, on a daily basis, you may want some of these bigger integer types. And for my text object, what I'm going to use here is a varchar. So this stands for variable character. This allows you to specify an upper limit on how many characters that could be. So for my name field, I saw was 28. I may not expect it to go higher than 50. So I might just put this as a varchar bracket 50. In other cases, I saw was pretty consistent there for RGB, where it's giving me the color of the actual block. For that to be 6 characters, that's not going to change. Okay, so here's my query. So this is based on these numbers. Changing, again, I've given a bit more space for things like name. Doing this means I'm allocating a lot less space on my SQL Server for these tables. So if I run this, I will now get tables successfully created. So I can go and have a look at the ERD for this. And here you can see. So this is much different. We've got colors table here, and it's got all those data types in there as well. So what I'm going to need to do is go and repeat this process for the next 7 tables as well. If you get stuck in this process or have some issues, do check the description for links to a solution to this stage. Okay, so after a bit of work of working out all those data types, I've now got my full list of all 8 tables that I can now go and write to my schema. These are essentially like the frames that the data is going to go into. So this defines the columns and the data types. So when I run my query, I've got an issue, and that is that colors, that table already exists. In some variations or dialects of SQL, you'll have the function create or replace your table, so you can just overwrite a table with a new one if it already exists. But in PostgreSQL, that's not the case. So what I'm going to have to do is check if the table exists and then drop it if it does exist. So I'll be using a function drop table if it exists, stating the table name. Then I'll run my create table statements. What this will do, we'll go and check if those tables exist. If they do, they'll be deleted or dropped in this case, and then I can create a new table without an error occurring. So here we go. So in the output messages, you can see here I get indications that certain tables don't exist, and that's fine. And then certain tables are create table. I can see I have all those tables there populated. Hey, this is Will from the edit. We lost audio here, but to tell you, what I'm doing is inserting the data from the staging schema into the analysis schema. So for each table, I'm going to write an insert statement, and I'm going to select star from my relative staging table to insert it. Okay, so I'm now just going to go and write this insert statement for all the other tables, and then I'll see you in a sec. Okay, cool. So now I've done that. I've got all those tables there, and I can now go and hit execute my script, and this will go and run through all of those queries. Okay, so I've got an error here about parent ID. I'm just going to have a look at staging.themes and see what's going on with this. Okay, so I've run this query, so I can see that parent ID was coming through as text here. I assume that's because of this null coming through here. I couldn't see any other reasons really why that would be considered text. So I've gone and done a cast, so cast parent ID as that data type small int. I'm now going to change this query here to include this reference in this part here. So cost as a small int. I'm then going to add in the other column names here, so we can just replace the select star. This is the beauty of this kind of where we basically remove anything that was already there and then just rebuild everything again. It makes it quite easy for fixing issues like this. There we go. So 2 seconds, done. Checking on the ERD, I can see all those column types have come through. That's great. I'm just missing all those connections, those relationships between the different column names. So that's what I'm going to add now. To do this, I'll be adding primary keys and foreign keys where appropriate to these tables. And I'm going to do this based on the schema diagram we saw earlier. So this ID field here would be a primary key. This identifies every row in this table. So you could identify every single row just by looking up the ID. It also adds that index, but it comes with the constraint that it can't be null, so you can't have a null, and it can't have any duplicates in it. So the sort of database integrity that you can identify every single row remains true. So that may cause some issues in uploading data. If you upload the same ID twice, there's going to be an error. Over here with theme ID, this is going to be what's called a foreign key. This is basically a primary key that lives in a different table. So the theme ID, the ID field, is a primary key here, and this appears in the sets table here under theme ID. Take a look at this diagram. I can see some clear candidates here. Like this ID field here feels like it's going to be a primary key for this table, and thus become a foreign key in this table here. Please be aware there may be cases where there isn't a primary key for some tables. That's just part of the design of the schema. So your primary key will identify every single row in that table. You may have cases where actually you have multiple of some ID matched to multiple of another ID, and that's just the nature of the table. So no primary key can be defined on that, and that is okay. So what I'm going to want to do is I'm going to want to alter my tables to add a primary key. So this is a term called alter table. So this is my function alter table. I'll then give it the table name and what I want to do. In this case, I want to add a primary key on this field called ID. You may see this labeled as a constraint. It is a constraint because then it adds extra criteria to that field where it has to be unique and it can't be null. For reference, alter table is where you would go to do any standard changes to a table. For example, if you wanted to add a column, if you wanted to update a data type, you would be using alter table. I run that query and that's been successfully done. I'm now going to add the other keys for all the other tables. Okay, so those all ran successfully. Now I'm going to need to go and add the foreign keys to this. And the syntax is the same. We'll start with alter table, but you have to define where that key comes from. Okay, so what I'm going to do here is I'm going to add in my foreign key. So earlier I put together the primary keys for these two tables, so part categories and parts. So I use the ID field here for part categories, which you can see there. I then use the part number here for parts. To add part category, this is a foreign key. It's foreign because it relates to this primary key but lives in a different table. So I'm going to alter the parts table to add a foreign key, but it needs to reference back to that ID field there. So this is our syntax for the query. So alter table on my original table, that parts table, I want to add that foreign key on that column name, and then where it references to, so part categories as well. So now if you go and reopen our ERD diagram, you may need to refresh it or reopen it again, but you can see that this has been made here. So this key symbol has now come up for our ID field that identifies it as a primary key. So then this line has been made to join from these tables to another. There's a bit of notation here to understand. So this line here means that one ID field here will match to multiple product category IDs here. So you can sort of see this line spreading out to multiple lines. That means it's a one-to-many relationship. Okay, so I just need to go and add all the other foreign key references. Take some time with this, go and check back to the schema diagram to make sure you're getting these right. And then you can always verify things are correct using the ERD diagram. Okay, so I got this error coming back on my inventory part saying this violates the foreign key constraint, saying that this value, like 48002, is not present in the table parts. So what that means is I have two options. Either I can give up adding a foreign key here because there's data in inventory parts that doesn't match across, or what I can do is I can add the data from inventory parts to the parts table and just have the rest of the column information as null. I'm going to have a look at how many fields are missing and see what's going on. Okay, so I've run my query. I'm going to just go and insert these into parts, but this is really good to know that actually we've got some information here that doesn't match across. This would be really helpful if you took this, say, data engineering team, say, we've got these parts, but we don't have a name or ID available for them, so what are they? Applying these keys can be frustrating at times because of the errors, but actually they do test the integrity of the data you have. So I've got my query here. I'm just going to go and insert this into the parts table as well. Okay, so my part type cat ID is coming back. So I need to go and cast null as not text. Okay, so that's worked. That's inserted my 21 rows. I had to go and cast my null to a small integer for part category, but that's okay. That's all worked in the end. And now I can go and check my foreign key constraint. And that works. Okay, I was just trying to rerun my entire script, but here has given me this, I can't drop this because it depends on something else, because we've added those foreign keys. So what I'm going to need to do is do this Cascade option here, which means I drop this and anything related to it. Okay, so I've gone and added Cascade to the end of all these drop table queries. You can see it comes up here with a notice but doesn't error out. This would just tell me about the foreign key constraint. Okay, so I did try and get it in the same format as the previous one, but you can see it's a bit nuts. So what you can do here is just go and do the auto align function, which turns it into this. It's a bit more vertically orientated, but thankfully if you hover over, you can see the relationship between the tables. These are really helpful diagrams whenever you're working with SQL. And the nice thing is with this as well, you can go and download this as an image. And this will be a very good thing to put in your portfolio to show what you've done the work, that you know how to set up primary keys, foreign keys, you know to set up proper data types, and to actually understand how you go and structure a schema. Alternatively, if you still have that connection from dbeaver from the previous setup video, you can actually go and create an ERD diagram there as well. If you right click on your schema and select view diagram, it will present to you the schema like this. And if you've got those foreign keys set up nicely, then you'll get something like this. Personally, I feel this is a lot neater and cleaner to look at, so you might want to try this. Again, this will be something nice again to put in that portfolio at the end to show that you can build these kind of diagrams. Okay, so this section is all about performing some analysis on this work. And what we'll do here is take an idea and then turn it into SQL code and then create a view from that. Using that view, you can then connect to another service, a visualization tool like Tableau, or you can download the data and then use that. Can take all the data here, join it all together, and then put it into Tableau to create like an exploratory dashboard to go and look at the data in different ways. That's one way, but I feel there's more analysis you could be doing in SQL to inform those kind of views. The way I like to do it is start with a perspective or a question in mind, and then use that to sort of start performing your way around these different SQL tables to produce a data set. So what do I mean by this? So for example, I've had people in the past where they've taken, say, a specific group of sets that they were interested in. So I had one person who was interested in the Lord of the Rings data. So they went and they analysed the sets of how does Lord of the Rings compare to other sets, and that made for a nice sort of topical perspective on this. You can also have a look at what's changed over time. So another example would be, say, looking at the colours there. So have the colours changed over time? Have there become more colours? Are there less colours now than there were before? Understanding that could be quite interesting. But it also has those business ramifications that every color is going to have a cost associated with this. So people may like all these diverse sets, but there's an impact to the business there as well. You could also look at the part. How many of those parts in sets are unique? I.e., do you have this one like Lego person only appears in this set and that's it? If so, there's going to be an extra cost associated with making that part. So I'm going to walk through the unique parts. I will stress that you can do whatever you like here. I've given you a few ideas to get started, and what it comes down to really is, can you talk about this project with interest when it comes to an interview? It's got to be an idea that you like the sound of and want to explore and have some motivation behind it, because this is what your interviews are going to want to know and want to see, that you are doing this and you're motivated, interested to learn more. You have that kind of spark that says, I wanted to do this piece of analysis. So if I want to go and find out where my parts appear, so I'm going to go from part num over here to inventory parts. I'm then going to go via this to inventories and then over to sets. So I then find out these parts appear in these different sets, and then I can do a count of the different part numbers and then see which ones are unique. Okay, so I've written a quick query to go from parts all the way to sets, and I can go and see some of that data here. So I can go and see part numbers and what they are. I can then go over here and see what sets they came back. So what I need to do now is just do a count of the individual parts and find out how many are equal to 1, and then work out where they came from. Mention it by set my search path up here to analysis. That just sets my schema to analysis, so I just have to mention these individual table names rather than the schema as well. So now my query is complete. I have this list, this column list of like how many hints. I can see already there's some here that are unique. There are individual ones here as well, which is cool. So now obviously I can actually find out how many there are by using a having clause. So this will filter that count, that aggregation there. So if I do having count equals 1. Okay, so it actually looks like there's a lot here. So there's more than I thought. So there's 11,000, nearly 12,000 parts here. Some of the eagle-eyed amongst you will have noticed inventory parts. It has a column called quantity in there. So for this analysis, I'm only really interested in the parts that don't appear in any other set. They are unique to that set, no matter how many there are of them. This is getting to the point that, say, they may have made a set in 2005 and then never use some of these parts ever again. So I've got all these interesting parts. What I want to do is try and get it on a set level. This then helps actually articulate what these parts are, where they exist, when they were produced, so you can have a bit of further analysis to that. There might have been a point in time they made a lot of unique parts, and is that still the case? Or are they having to make more unique parts to get more people interested in the sets? So what I'm going to do is create a data set of all the sets and the parts related to them. But now I can go and tag up which parts are unique and which ones aren't. Okay, so I can just go and query, go and put that in a common table expression and query it, and I can see that's coming back. That all looks good to me. So now I can go and join this back into existing work I was doing before. So I can actually just restart this analysis where I was and then include this as a left join in there to tag up those unique parts. Okay, that's come back, all good. So now I've got the same data set as I had before, but I should have this extra part number coming here. So where you see a null here, that will mean that it's not a unique part, but where you see a value here, that means it is a unique part, so it doesn't appear in any other set. So what I really need to do here is actually just tidy up some of the columns here. I've got too many coming in. I've got some that are named, say, part number, but this is actually a unique part, so I want to go and change that. I'm going to go tidy up this select statement, go and bring back the columns I need, and then see where I want to go from there. I've got some information here. I actually want to bring back a little bit more, so I know there's a set year, so year it came out, as well as like a theme as well. So I'm going to join to that theme table, bring back that name, and add in that extra set year as well. And now I'm just going to go and reorder some of these columns. Okay, so this looks good. So I've got some ideas of themes here. I've also got some different part names and what's unique, what's not. I then have the individual part numbers. So what I can do here is I can just do a count of the different part numbers and aggregate by this. That should then tell me, so there's some of that column will tell me the total number of parts, and then I have the split of which are unique and which are not. So for this, I'm going to get rid of part name. I'm then going to do a count. of parts number. Now, I'm never a big fan of doing a group by on a case expression because that can be quite annoying. So what this is doing is just a shorthand way of saying I want to group by columns 1 to 4 rather than specifying the name or the formulas involved or even this case expression. Okay, so now we have a nice like output table of say some unique parts, some not unique parts, by different years, by different sets as well. What I'm going to do now is go and create this as a view. So in the same way we were creating tables earlier, we can come to the top here and go create view. So I'm going to create this as a view called unique parts, and I'm going to hit the execute script. That seems to have worked. So yes, my view has been created. So it won't appear as a table. What it will do is appear down here. If I go and refresh my schema, should have my view there. Nice. Okay, so this is my view that I've created. Views act very similar to tables, but are different in certain ways. So if I run this, select star from unique parts, so my view. So it takes a little bit longer than a standard table, and that is because a view is this query has been stored as the view. You can actually go and see what that query is if you go to unique parts, right click and go properties. Over here you actually have the code that is part of that, so you can actually see what's going on here. There's some bits here that I didn't actually do, so when I group by 1, 2, 3, 4, that has gone and grouped by that as well, which is nice. That is the main difference. So a view is a store of the query. With that comes the benefit that if the source data has been updated, those changes will flow through into the view. So when you select star from view, if there's been a new year added, that will be present in that view. Okay, so I've done my analysis here. What I'm going to do is save this SQL query, and then I'm going to go and connect this view to Tableau Desktop. This is the paid version of Tableau. You can get it on a free trial, but if you don't have that, you can always use Tableau Public, which is the free version of Tableau. You won't be able to connect to a database, but what you can do is here is go and save your results to a file and then connect to it that way. Okay, so I've got Tableau open. What I'm going to do is, as I'm in the professional version, I'm going to go over here to go to more. I'm going to search for Postgres. I'm going to connect to it this way. So I'm going to enter my server details. So it's going to be localhost again. Database I'm looking for is Lego. Username, password. So I have my Lego analyst. Okay, I signed in and I'm all good. I'm in. But if I try to bring in my unique parts, I'm getting this. So I'm getting permission denied for schema analysis. Position 15. That doesn't help too much in this case, but I think it's this issue here. What I need to do is trying to work out what permission I'm missing. Remember, you have access to the database, you have access to the schema, you have access to the individual tables as well. So we need to go and check which ones I'm missing. Now, as I can go and see all the tables, I'm assuming I've got access to the database. If I try and bring staging, so that other schema we had, that works. So that's okay. I would say to bring analysis, yes. So okay, so it looks like my Lego analyst user is missing the permission to access this analysis schema. So I just need to go and grant them access to the schema, and then I should be able to access these tables. So I'm back in Postgres. I'm just going to run these two queries. So the top one will grant me access to the schema itself, and the next one will just guarantee I have select access to that view that I've created here. And there we go. So that was the issue. So that's coming through. Let's go and update this. I'm going to change the connection over here to an extract. The reason being is that otherwise, whenever I interact with the visualization, it's going to be sending queries to my Postgres database. I want it to work locally here rather than adding more queries and workload to my database here. It also should be a bit quicker if I'm working locally than having to send messages back and forth. Okay, so I've gone and saved that extract. I've also saved my workbook as a TWX file. That is important because that will contain the data source with it. So you just have one file, visualizations and the data source connected to each other. When we're in Tableau, it's all about exploring the data, but also having a bit of purpose to it. So we started with that point of analysis of understanding unique parts. So let's go and see what they look like in terms of a proportion of all the parts that we have. First up, I would start by putting the dimension unique parts on rows, and then on columns, I would go and see what the proportion of these are. Well, you can see these here as numbers. You can show these are mark labels, yes. I can also go and change these with a quick calculation to percent of total. So I can actually see it, just only 2% of parts are unique. And of course, it doesn't have to be a bar chart. We could go and change this to things like pie charts. If you go and select pie on marks, it looks a bit weird. But if you go and change sum of parts, move that over to angle, and then change unique part to color. So you can see that's been made there. And then on labels, you can bring unique part name on there as well. With then, if you hold down Control, some parts there too as well. So now we've worked out how many there are. It's good to then explore how this changed, say, over time or with different sets, to see if there's any potential sets that have more unique parts or any reasons behind that we can deduce from the data. So let's go and open up a new tab. So what I'm going to do, let's bring parts back on here. Let's bring that unique part color on there. We can see that down there. And let's bring in the set year. So Tableau has changed this to a line chart, and this is a really interesting trend because you have a dramatic increase. Number of unique parts has gone up substantially, relatively unique parts has gone up quite a lot, but actually that's probably because all the parts are now producing many more Lego sets each year than ever before, and that's kind of been a trend that's going on since the 90s. But if we want to understand how the number of unique parts, what we can do is have a look at this on a percentage of total basis. So if I was to say change this to a bar chart, back to a bar chart here, you can see those coming up, but I want to change this sum of parts, quick calculation, percentage of total. It's computing across, so I'll go and compute down, and that will give me that percentage there. And now you can start seeing little bits here where actually 1955, we actually had almost 10% was unique parts that have never been used again. I think some of these older sets, you'd hope that they were being reused in the newer sets, but even here we can see some of these sets creeping up. It looks nice. What I'm going to do is I'm going to duplicate this sheet. Okay, and now I'm going to go and change year. So I'm going to go and change this for the set name. So now I have a sort of all of these. So as you can see, as I scroll down, some screws from motor case. That sounds like a fun set. Scratch and Scratchy, nice. Scurvy Dog and Crocodile, what a set. But what I want to do here is I want to focus on these unique parts. So what I'm going to do here is create a calculated field for unique, and then I'm going to go and sort by that. So how to do this, so I'll go onto my unique parts, I'll go create calculated field. Okay, so this calculation will just pick any fields that are unique. Any that aren't unique will not be counted, so that will be okay. And I can see this, you can always just double check a calculation by bringing it in as well, just to see what it looks like. And now what I can do is I can go and sort my set name. Okay, so that's doing the unique parts, but it's not really doing what I wanted it to do because I wanted to do the percentage. So what I can do is then go and duplicate this, edit this calculation. So what I'm going to do is I'm going to change this into percentage by just dividing it by the total number of parts for each set. So I'm going to click OK. I'm going to bring that into my visualization. And it looks kind of weird because it just looks like something's gone wrong here. But the reason is because it's doing this split by the color on unique parts. If I remove this, then I can see that this actually looks a bit more what I wanted it to be. Okay, so I can go and now change this sort. And there we go, we find quite a lot of sets that are fully unique. And so I want to try and improve what these sets look like. So what I'm going to do is go and add in a bit more metadata. So I'm going to add in like the theme for each set. So there's a 12-volt theme going on here. I can also add in that year again. So that's coming through as continuous. So do this annoying thing where it goes and splits it by that axis. But what you can do is go and change this to discrete. And then that will come through like that. What I'd also want to include probably is the number of parts. So maybe have that as discrete as well. Yeah, so in some cases here I can see there's some that are very... so what it's doing here is it's splitting these out because of parts here. So what we can do instead is we can use a level of detail calculation. So what I can do here is I can right click on parts, go create. Level of detail is basically like an aggregation in SQL where you say I want to group by certain columns. So in this case, for fixed, I would want to group by the set name, and I want to sum the number of parts. So this will give me a total for the parts for every other column that's in that data set. See, I've got the same number here, but it's not being split. So this total here, so 2 and 58, now is 60. So I can now remove parts from this. And there we go. So I can get my little subtotal there. I might also bring out the themes itself as its own bar charts. So let's duplicate this again. Okay, I think this is a bit more interesting. So I've got a few charts here that I can now go and bring into a little dashboard. So get rid of the phone view because I'm not doing that. My desktop browser. You can always make this a bit wider depending on your screen. Quick tip, if you do automatic, that will go to your screen size. And then if you do fixed, that will tell you your screen size. So I always like to go from this and then do a little bit smaller. So while we're here, we can just bring out our different charts. Okay, so how we want to design this. So it's not very helpful at the moment. Always have a title. So I'm going to add this dashboard title up here. But you always want to start here in the sort of top left with like the most big picture kind of view. So in here, this would be my 2% of unique parts. I then might want to split down by how has this changed over year, and then look at the themes, and then an exploratory view at the end for people to go and have a look at all the different sets as well. The idea I've got with this is that it'll be all clickable and explorable, so someone could say click for a year and then now update for the different sets or the different themes that were in that year. So let's do that. Okay, so I made a few updates, obviously, to this. Here's a few tips for you. So I decided actually I like this analysis piece of actually saw this growth in the number of parts being made available. So I like that. So I added that back in. I then split out the percentage of total unique parts into another chart because I felt like there's two like stories going on and one chart wasn't kind of telling both of them for me. So I can split them out. What I've also done is I've tried to update my titles to be more informative about the actual narrative here that I've got. So often your users the first thing they'll read is the title. So if you try and put some insight in that can help them understand what's going on or take something to take away at the end of this. Lastly, I got rid of the legend and I started adding the word unique parts in here as red to kind of give that visual cue that these are the unique parts and these are the not unique ones. And also just a bit of spacing here and there. This will be available on my Tableau public, so you can go and download it there and have a look at what I've done. in terms of some of the finer details. Tooltips I've tidied up and like made the font a bit larger as well. The last thing I've got to do here is now go and add some interactions. Action. So I go and add action and add a filter. So this will be what you click, which will then fire the action. As I want to run this by the theme, I don't want it. It's only going to run from the themes sheet. So if you go Control A and untick all of those, and then just tick that one, and then here you can untick themes. I think the others will be fine. If we do show all values, and also change this from menu to select, selected fields, go and click add theme name, go OK, go OK. So hopefully, I'll click here. Whoa, yeah, that works. Okay, and lastly, I've just set up an action for year, so I can go and see, interact with, say, 1955. See what. Now, if you add interactivity to your charts, make sure you let the user know about it. So I'm just going to write little subtitles under these to say that they can click a bar or click a year to go and filter the other charts. Okay, I had to rejig some of the titles there to make sure that these fit in, but I'm happy with this. Okay, so a few design tips I've done here. So I made the title quite big. I've made this color scheme. I've gone away from the default colors. It's always a good option to do. Other things to watch out for, I've named all of my sheets a good name. Similarly, I've named all my calculated fields a good names. These always stand out positively, so some interviews will actually go and look and see how well it's been constructed under the hood. So now I can go and save this, and what I'm going to do is go and publish this to Tableau Public. Okay, so now I've got my dashboard on Tableau Public. What I'm going to go and do is go and download an image of this to go and use for later. So the last step for this challenge is actually to go and put your work on GitHub. This is a fantastic place where you can not just show off visualizations you've done like on Tableau Public, but you can bring in all the code you've done, all kind of blog documentation, whatever you want. There it can be effectively be your own blog site to go and show off what you can do. So for me, what I've put together with this challenge is a template README. So this will give you a little bit of guidance on how to go and structure a README. I give you this template here, which is based on a project I did about the Tour de France. So this is the final part. This is the real final hurdle of selling yourself, is to talk about your project, what you've done here, what you've investigated. You can use certain tools like ChatGPT to help you. So you can say, give ChatGPT your SQL script and say, hey, can you explain what the script means? And that can help get over some of the writer's block elements that there is with documentation. I don't think it's a bad place to start in terms of an outline of what to say. I will leave it up to you, and I look forward to seeing all these great projects that you have coming out. Until next time, bye for now.